All right, guys. Next section is going to be talking about where a function, or the intervals in which a function is increasing, decreasing, or constant. So, when my graph is going down from the left to the right, we're going to say that area is decreasing. Where it stays constant, where it's a horizontal line, is going to be our constant. And in terms of x, if my graph is going up from the left to the right, we're going to say it's increasing. Right? The big idea, most important idea, is you need to understand that it's in terms of x. We always write our increasing, decreasing constant in terms of x. So, if I start over here on this graph on page 57, number 32, as I walk from the left side to the right side, my graph is coming down. So it's going to be decreasing, and when it hits this point, it changes directions. When it hits 2, when my x is 2, my graph starts to increase from the left to the right. So over here, on the left side of 2, my graph is decreasing. On the right side of 2, it's increasing. So writing my interval for my decreasing, it's from negative infinity to positive 2, parentheses, parentheses. All right. This, if you put a bracket on the 2, I'm okay with that, but I would prefer parentheses. And to the right of 2 to infinity, my graph is increasing. So you've got to decide where the graph changes directions. And then write the intervals in terms of x. To the right of 2, which is greater than 2, it's increasing. To the left of 2 or less than 2, it's decreasing. All right, for number 36, we have this rational function. All right. First thing we need to recognize is that I have a vertical asymptote at -1. That means my graph does not exist at -1. The next thing I'm going to do is I'm going to draw light lines where my graph changes directions. All right, so now I have 4 pieces. From the left to the right over here, my graph is increasing. This little section down here is decreasing. Back up to here, it's decreasing again. And then to the right of this point, it's increasing. Reading it from the left and to the right. So I'm going to have 4 answers. My graph is increasing first, from negative infinity to what is that, -1. Then my graph decreases from that -1 to 0. No, I'm sorry. I messed that one. Back up. It's increasing from negative infinity to this point, which is -2. And then it's decreasing from -2 to that vertical asymptote I have, -1. I jump on the other side, it's decreasing again from -1 to 0, and then from 0 to infinity. It's not a continuous function because my graph is broken right here. So I have a section of something that's going on here, 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 and here. So I have to write 4 different intervals where it's increasing or decreasing. All right, this last one. All right, I'm looking for where it changes directions. Here's my point where it changes. And this is where it changed. So looking from the left to the right first. As I walk along here, from the left side up to 0, my graph is increasing. From 0 to 2, it's constant. It's staying the same. And lastly, from 2 to infinity, it's increasing again. So this time I don't have a decreasing. So I'm going to say from negative infinity to 0, increasing. From 0 to 2, it's constant. And from 2 to infinity, it's also increasing. So you've got to look at it. It helps at times to draw those vertical lines to the x-axis so you know where it changes directions. I'm also going to add that asymptote. That's 3 different ones. Here, it changes directions at 2. And that tells you where, and write on the graph if you can, or make a basic sketch. All right, last part. Make sure, but pretty sure it's the end. All right, we're going to talk about relative mins and maxes. A relative minimum is the point where your graph changes from decreasing to increasing. So my graph's going to be going down, 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 down. It's going to hit a specific point, and then change directions and start going up and increasing. That's a relative min. It's a bottom point. A relative max is where my graph increases, hits a point, and starts decreasing. Min is going to go down, then back up. These are your mins and maxes. So we got to be able to pick them out. So looking at number 56 on number 8, or page 56, number 8, we have this graph. All right, so we're going to ask for 2 things. Find the zeros. So I'm going to look on the graph and find out where it crosses. And we're going to say my zeros are at -2 and 1. All right. We remember, hopefully, this is called a double root. That really is the answer 1 twice. If it touches but only doesn't cross, it's called a double root. All right, we'll talk about it. We'll get into that a little bit later, but it's the same answer twice. All right, so we get rid of that. It doesn't really matter for this. All right, my zero is at -2 and 1. All right, starting on my left side, going up. Over here, my graph is increasing, and then it starts to decrease. So this point right here is going to be a relative max, and that's -1, 1, 2, 3, 4. That's a relative maximum because it's a high point. This point down here is decreasing and changes to increasing. It's going to be a relative min, and that's 1, 0. So we just got to look where the graph changes directions, from going down to up or from up to down. All right, and last one. My zeros are at plus or minus 1. But now for my relative mins and my max. Do I have any points on this graph where my graph is going down, hits a particular point, and starts going back up again? That would be a relative min. A relative max is going to go up, hit a point, and it's going to go down. And for this problem, I'm going to say it has none. No mins or maxes. Because it doesn't change direction. It decreases, hits a point, and stops, picks up again, and increases. It's not a continual function. It's not continuous. So this has no relative mins or max. If I gave you this, maximum, min, max, all of these. All right. If it hits a point and changes directions, that's the relative min or max. All right, so here's your homework. It'll be on the classroom. If you have any questions, please let me know. Have a great one.